Okay, I think good morning, everyone. So I have to little change. Let me do that. Hope you can see my screen.
Yes.
Thank you. Okay, so good morning, good afternoon, good evening. I think there's no good afternoon, by the way. So good morning and good evening to everyone, depending on wherever you are. Thank you for taking time to attend. On behalf of All India Oracle Users Group, very warm welcome, Sangam 20 Virtual Conference, a festival of Oracle. It is already a week 2, day 7, session 1. It looks like statistics are increasing. So before I introduce our today's keynote speaker, I would like to cover a brief overview of Sangam 20. If you're joining first time, for others maybe it's a little boring slide, but just keep focusing on this picture. So we are going to ask some question on this picture in upcoming days, right? As you can see, Sangam 20 is a 12th anniversary, 12 days of festival. It's basically bringing all 12 months of knowledge into 12 days. So that's why it's in the December. And I think this is the last conference of the year from Oracle type of conference. We are bringing a best of Oracle technology to you. And it is, 3-week festival, as you know, and also 100 plus speakers joining across the globe. We worked very hard to get new speakers and new contents, and there are some speakers you can't avoid. They are the rock stars, right? So I think you guys know whom I'm referring. Uh, we have introduced a new themes, rapid fire sessions, and tomorrow is also a big day for us. Just wait for a few minutes what we are going to announce. And also we have community sessions and not to miss the magic of Sangam 20, right? So today we have analytics, machine learning, even operating system. There's a one session from Glenn. So it's all a mixed technology track. So do not miss. And today is a Saturday. I'm sure there is no excuses, right? So you need to maybe take a permission from your family, but please attend and make it a very successful conference. It's not only attending, right? Please be interactive. Ask as many as questions, right? So that's really, we are very poor in that category. Please ask more questions. And again, this is very important slide. You can take a screenshot of speaker, or you can take a screenshot of this slide. Please tweet in Twitter so that your connections are also can join from today or tomorrow. And this is not only just your connections, right? You are making a new connections using this platform. And few housekeeping, as you know, ask all your questions in Q&A. If you need any support, ask in chat. Continue your conversation. We'll upload the presentation material in our website after Sangam 20. And today, as you know, keynote sessions are very key for us. Please participate in the quiz, chance to win a gift vouchers, right? And survey, right? So provide you its speaker feedback, as well as if you want to ask more about in this particular session, please provide that in a speaker feedback. Um, with that, I'm just thinking, do I need to really introduce Sandesh? But I think I'm just going to play one video. I'm not sure how many of
I
you.
wasn't born there, but I spent
Um,
most of my
so if someone just confirm me this sound is coming or not, Vinay or Aishwarya.
Yes, it is.
Mumbai. It
Yeah.
was challenging, whole bunch of innovation happening. The internet suddenly changed everything. I'm a constant fan of learning. I think that's kind of the number one thing that keeps me going. I can't be static. I just have to constantly either tinker on something, learn something new. I've traveled to more than 700 plus cities in my lifetime. I can speak 8 languages fluently. I'm learning French and Spanish right now. Anything new I like to learn. I track and measure everything, not because I'm just doing it because of the sake of doing it. I like to improve myself constantly. I've actually spent my entire life trying to work on IT and IT-based technologies. Now, IT-based technologies can be really boring, can be really complex, can have a lot of data to go through, and usually to get results out of it, it's extremely difficult. We started applying AI technology on top of data that basically comes from all these IT systems. My team is responsible for this thing called AIOps in the autonomous database. You want people to be able to manage extremely large cloud environments without actually having to know about it. So the ops person just has to go, press an easy button, and something fixes itself. My team builds that stack. So we deal with some extremely complex problems where we can predict machine failures. We can predict when a customer should be allocating more resources to their job so they can finish faster and makes them more productive. All this stuff gives an immense amount of availability, reliability, and takes out complexity from IT infrastructure and lets the developers focus on one thing: build stuff. That's what the autonomous database is all about. It enables businesses to discover the true value of their data. Solving these use cases are very important to customers because otherwise customers need to solve them. And every customer will develop their own method of trying to solve these things. They're not exactly efficient. The two things in any AI problem: access to humongous amounts of training data, and second is applying the right algorithms to it to get the results. We have the data, we have the resources to apply these algorithms, and once we apply them, whatever results that come out of it, we can apply them to a whole bunch of customers, and everybody benefits without each of every one of them having to reinvent the wheel on this one. That's why it's very important to take the collective intelligence of what we develop in the cloud and apply this to all customers so everybody benefits. If I ask you to keep your phone running, that's extra work for you. That's not what you bought the phone for. You want the phone to just run, and you want to work on the application that's on the phone. And that's what AIOps does for you. It takes away all this complexity so that we apply collective intelligence, data, and algorithms that we have applied across a whole bunch of customer scenarios, and everybody benefits. As a vision, basically all data as a data platform will be manageable under autonomous. No matter what kind of data you have, no matter what kind of format it comes from, we will know what kind of data it is and we'll be able to apply the right algorithms through it. So we're a data management company, and we'll continue to get better and better at data management to be able to unlock all these innovations for customers.
So with that, do you need really introduction? But just from a personal point of view, right? Professional anyway, we are covered in that video. So Sandesh is one of our motivation behind this entire platform and is so energetic. I don't know how many of you met Sandesh in our conferences. So energetic, so energetic. I think we should ask what's the secret behind that. And I don't know how many you actually follow him in Facebook. And anyway, so we want to give that experience a check, and he's the person behind the scenes for our energy and motivation, whatnot, right? He's a big brother, and also we are really missing his company face to face, but this is the best thing we can do in the virtual world. So with that, handing over to our rock star.
Hey, thanks a lot, man. This is pretty cool. Hang on, let me just enable sharing on my. Can I share, Sai?
Yes.
All right, give me a second. All right, can you see?
Yes.
All right. Sweet. So thanks for that awesome introduction, Sai. I see myself as a motivational speaker and a part-time technologist. That's what Sai keeps telling me. And I should probably become a motivational speaker because I'm getting more and more better at it. And technology seems to be something that's in the rare screen now. But I think most people know what I do. I basically work on AI ops, and I like all things AI, but I'm a hardcore database guy. Work on all things cloud, and I've done a whole bunch of things in my career, but they're probably not interesting from a point of view of this presentation. So let's go right into it. So I remember it was 2019, and we were in Hyderabad in Sangam, and we had just started the conference, and a lot of cool stuff happening around. And it was like when one of the most important questions in all DBA's minds were, hey, what am I going to do with all this new autonomous stuff coming out? And I told these guys that, hey, you need to use machine learning as one of the tools in order to get started. So let's do a quick recap, shall we? So before we get into this, I just wanted to clear the subject of what this is. Then we'll do a quick recap. So what is AutoML? AutoML basically automates all the steps and all the things that you do normally in a machine learning model generation task. You don't need to know anything. You just, without writing any piece of code, you can drag drop things, and basically this thing does everything for you. And that's basically what AutoML is. So in order to come to this, let's take a step back. Sangam 2019. So this is pre-COVID. That video was pre-COVID. It feels like it is from a different time. So I thought I'd put a couple of slides for people to understand, for those that didn't attend my session last year, as to where this whole thing coming from, right? So there's these different forms of machine learning. There's supervised, semi-supervised, unsupervised, and reinforcement learning. Most of the stuff I've spoken about falls into the semi-supervised and the unsupervised area. We covered different kinds of algorithms. We covered regression, which is basically for tracking housing price estimates, optimal pricing, customer lifetime value. We covered classification, which is basically trying to compare a whole bunch of things and then saying, okay, based on these labels, what is this new thing? And is actually used to identify things like who's the customers that are coming and buying things without a discount, or fraud detection. We went into clustering, which is an unsupervised learning technique for identifying things that are similar. And those are for customer segmentation, credit risk evaluation, and document similarity. Then we spoke about anomaly detection. Anomaly detection is the way to basically look for something that is having a different variable rate, or having a variable that's moving out of sync as compared to something else. A CPU utilization of a machine that's more than 90% and it stays on Thursday morning, which is normally not the case, that's an anomaly for me. So identifying anomalies using anomaly detection. And then I went into this example where I kind of graduated from what basic stuff can be written with SQL, like a simple SQL query. I want to know the age, I want to know the gender, I want to know the marketing preferences. Simple. Then we went into analytics, where you were using something called RFM, or recency, frequency, and monetary value. And that helps identify what items this person has bought and what are the value of those items in the last couple of months. And then you start segmenting these customers into different categories, whether they are a new home mom or they're basically a young, successful startup guy, and what are the chances they're going to buy their products. So we're using those previous algorithms I mentioned to do all this. And then I mentioned something about an ML workflow. You pick a use case, you gather your data, you clean it up, you identify the predictors or the input features from this data, and then you help identify what are you going to do from an efficiency perspective, which algorithm you're going to use. And then you also take the input data, which is called the training data, and then you apply this algorithm to it, and then you tune the hyperparameters. And then once all of this is complete, we get a model. And then you keep doing this entire process again and again till you get a model that you like. Now, when I spoke about this stuff 2 years ago, and I mentioned this in Sangam 2019, there was a huge emphasis on a lot of this stuff was manual. And AutoML was sort of on the horizon, where it was starting to automate a lot of these tasks. Now, AutoML is not just automating. It automates in a very smart way, and it allows you to do a lot more things as part of this entire machine learning end-to-end workflow as compared to what we used to do. I mean, even 2 years ago, we did a lot of this stuff manually. And if something would change, we wouldn't know that what aspect has changed and which has messed up my model. And I have to go back to the previous model, but I'd spend a lot of time debugging what is wrong with this specific model. So this is a classic ML workflow. And I also covered use cases where we use all of this stuff for identifying signatures, defects, metric and log anomalies, as well as workload, stability, and performance issues within our cloud. Now, all this was Sangam 2019, but it's important to mention it because you get the context of where I'm coming from. At that time, these were the conclusions, and there were two conclusions particularly that stood out. The modeling in ML infrastructure is going to become standard. So AutoML is going to be everywhere. And getting the right data to train matters to have a successful outcome. This is where my presentation ended in Sangam of 2019. And I told these guys, hey, AutoML is coming. And this is going to change things dramatically in the next year. And here we are. So now, what is the difference between these things? By traditional default, machine learning has to be, in order to improve the accuracy of these models, you have to take them through repeated retraining cycles. So you have to take this, you have to pick the model, you have to evaluate the model, you have to take the algorithm, you have to do the feature selection, and you have to tune it. Keep repeating in steps. And that's where you start going from ML to AutoML. So why is AutoML popular now? So what is AutoML? So AutoML is like it's not an Oracle specific thing. AutoML is something that happens across various companies in various suites. Like, for example, even TensorFlow has AutoML, OML has AutoML. Oracle has got a data science cloud, which uses all open source stacks that has AutoML. So basically what AutoML is a platform that allows you to automate significant amount of machine learning tasks. Remember, a platform. So whatever you have as algorithms and a loosely lit set of code along with your training data today, you spend a lot of time setting up this platform. So I'll give you a couple of examples. 2 years ago, we'd set up our own Docker and Kubernetes containers. We would run our own tests. We would figure out and compare the scores. We would go and find out, oh, this is bad. Okay, hang on, which model was the one that was good? And we'd run some greps on the scripts, and then we'll find out which model was good. We'd have to write scripts to loop different hyperparameters and play around with this stuff. There's a couple of open source frameworks that came out, but they took a while to get into the market. So there was no platform to do all of this in a fashion where someone could just do this on a mass scale. But what has changed right now? The first thing that has changed is basically cloud-based accessibility, right? So all this stuff usually runs on cloud. CPU or GPU irrelevant, but nonetheless, most of the stuff happens in the cloud because you don't want to be in the platform business. You don't want to set up machines. You don't want to set up GPUs. You don't want to move your data from object store to a database or object store to a pandas data frame where you want to process all of this stuff, or something that's in an Oracle database, you want to get it into a table and then process this using OML. So the platform needs to be a given. You don't have to set up the platform. So cloud allows that thing to scale up your compute while you can concentrate on your machine learning tasks. The second thing that's happened is there's a massive growth in open source and commercial AutoML libraries that has expanded the scope of what AutoML can do today versus what it did 2 years ago. And third is a lot of people investing in AutoML because of the benefits it gives to data scientists and their organizations. If data scientists do not need to set up a platform, it is huge. I'll give a simple example, right? I have data in my Oracle database. If I have enabled AutoML that allows you to train a model without knowing a single line of code, just doing a couple of drag and drops, as a data scientist, you can find a lot more interesting things in your data compared to, oh, what if I have to create a table? I have to ship this data from an object store to here. And then what if I run out of CPU? There's so many things you have to think of when you're thinking of infrastructure. So AutoML takes away all of that and gives you a ready-made infrastructure to basically run all of these things. So does it mean that, oh my God, I started studying, I listened to Sandesh last year and I started studying as a data scientist. My job has disappeared before I even started. No, that's not true. What this does is it doesn't replace data scientists. It actually makes their capabilities even more stronger. So this is like an example of the assembly line in manufacturing, right? So when you started, when cars were built, everybody would actually build cars manually. Like someone would come and set up something and someone would start going and fixing things. And then Ford came along and built this automated pipeline of stuff. And then people are like, oh my God, our jobs are gone. But what actually happened was this streamlining of building cars in an assembly line enabled people to put their time and energy into bigger issues, from quality to product improvement and manufacturing process and automation of factory perspective. And that has shaped companies like Tesla today that build a mass amount of cars with a massive amount of technology and electronics in it. The same thing what AutoML does is it gives data scientists to spend more time on designing what features or predictors to pick, what information pipelines we need to build. How do I fix that business problem without actually getting into the details of how do I get there? So AutoML doesn't remove the need for data scientists. It enhances their ability to get to a solution
faster. What is a classic AutoML pipeline? A classic AutoML pipeline consists of these steps. You identify the algorithms, you do adaptive sampling. So, remember the optimizer, right? The Oracle optimizer, you run a SQL query. What does that do? It scans against the stats, it looks at cardinality, it looks at selectivity, it figures out if you have histograms against your data, and automatically it charts a plan. And based on the plan, it decides, oh, can I do a hash join here or not? Can I do a subquery inline merging or not? Or should I use a transformation here when I'm merging along with these multiple tables? So the optimizer goes through all of these things based on sampling a certain subset of statistic data that it has in these tables. And it figures out this is the best optimal way to execute this query. Adaptive sampling is something very similar. It allows the machine learning algorithms to scan and figure out which algorithms will be more suitable for this kind of data. So that is called adaptive sampling. We'll go into details into each of these and what these steps are. Feature selection is, again, when you're selecting a certain set of input variables, it decides what input variables are the most relevant for your algorithms. And then there's hyperparameter tuning, and then you finally get the tuned model. This is a classic AutoML pipeline. Now, the first section, what is algorithmic selection? Now, there's a couple of things in every data set, the shape, the feature correlations, and something called meta features associated with algorithms. What we do internally is we invoke these things, what I call score prediction meta models, to predict algorithmic performance against different data sets in different domains. We know, based on different kinds of data sets, which model works well with what. And when we scan your data set, we can figure out that this data set is an insurance data set. This data set is, say, a fraud data set. This data set is a shopping cart data set. Or this data set contains descriptions of people. So we know, or this is a social security / whatever data set. So we know a pattern. Based on these patterns, we can automatically rank the algorithms on what their predicted performance will be. Sometimes you can't just use existing models to do this. You have to actually run the algorithms against the data and figure out which one actually functions well. So I'll show you how all this works together later, but understand the individual concepts here. So the score prediction models allow you to decide which algorithms will work well on this sort of data. So what AutoML does is it efficiently identifies the algorithms and the models that works for this data set that you have basically given. So that's the step number one, algorithmic selection. The second step is adaptive sampling. You take a piece of data, you sample it, you scan it based on that score that you get when you run an algorithm on it, and you keep optimizing it till you get the reduced data set that is more than adequate for finding the solution to this problem. Now, why do you reduce a data set, right? Remember this, the larger your data is, the more number of features you have, the more time it's going to take for an algorithm to converge to the results that you want. It's very simple, right? So if I have a table with 1 million rows and I scan 1 million rows, but I'm only extracting data from 5,000 rows. So I should ideally only have scanned 5,000 rows. I should not have to scan 1 million rows. That's what this is. It tries to identify what those 5,000 rows are, and it makes that a reduced data set till the score converges to a point where the score coming from this reduced data set and the score coming from the original data set do not diverge too much. So it is an adaptive representation. A very good comparison against this is dynamic sampling in the optimizer. What percentage of the rows do I need to dynamically subsample where I can derive a score, where I can assume the rest of that score applies to the rest of the rows, and I don't have to scan all the rows to figure out the access patterns. That dynamic sampling is like adaptive sampling in machine learning. So this identified sample is used for subsequent stages of the AutoML pipeline. An example for this is called n-fold cross-validation. What is n-fold cross-validation? Assume I have a cake, and I cut the cake into 10 parts. So it's called 10-fold cross-validation. I take one piece of the cake and I run the training with that one piece and I run the testing with the remaining 9 pieces. I don't eat the cake. I put the cake back and I take the second piece of the cake. Then I run the training with the second piece of the cake and I run the tests with the first and then the third onwards till the 10th piece of the cake. And I continuously keep doing this. What does this give me? One of the biggest problems in a model is overfitting. When you do this, you basically avoid overfitting. But you could always, if you optimize your n-fold cross-validation, you could pose a problem of underfitting, which could also increase something called induced bias. Now, what does all this stuff mean, right? When you study for an exam and the exam paper looks exactly like the textbook, that's one scenario. The second scenario is the exam paper doesn't look like anything in the textbook. So if it looks exactly like the textbook, it's underfitting. If it doesn't look like anything in the textbook, it's overfitting. You don't want either scenario because it means that you're going to do bad in the exam because you were expecting something slightly different from exactly what you studied. And the model is not going to be realistic in evaluating that situation. So you use this method, k-fold, and this fold iterates between becoming part of the testing and the training set. And it reduces two things, bias and variance. Now, of course, we need to have a full day machine learning session to go into details of all of this. But remember this, an n-fold cross-validation method reduces bias and variance and tries to figure out what data is the best combination of the test and training set when you're doing adaptive sampling. So this cleans up your data and sorts them into test and training sets so that your algorithm performs the best. That's what this adaptive sampling procedure is all about. Then you go to feature selection, where you try to pick all the inputs that you have. Now, as part of feature selection, you can go and say, the fewer the features you pick, the better it is, okay? And the algorithm automatically orders these lists from the most to the least important features. And then it identifies what is the optimal feature set. And it pairs that with an algorithm. Now, the volume of features, the number of features that you use, if they are extremely large, it slows down the entire process of feature selection. And PCA is one such method of doing feature selection, and it completely slows all this down. So it's very simple. I'm writing a SQL query. If the SQL query has 2 columns versus 20 columns, the amount of data you're going to pull from the table is going to be a lot more. It's going to take a lot more resources. If I have where clauses, group by clauses, it's going to take a lot more work. It might take more time. The same concept applies to feature selection. The fewer the features you pick, the right features you pick, it improves model build and score time, and it makes the entire process a lot more faster if you pick fewer features. And what AutoML does is picks the right combination of features and algorithms to say, hey, this is the right thing to do. Why am I explaining all this to you? As data scientists, you will not have to see any of this or understand any of this in order to use this. But it's always good to understand what is the underlying mechanics of how this thing works and what task it is actually automating for you. So in this case, this is feature selection. Hyperparameter tuning to an algorithm is like what an init.aura parameter is for a database. Each algorithm has got its own set of hyperparameters. Now, which hyperparameters for which algorithm in combination with which adaptive sample gives you the best combination? So imagine a Cartesian product of all these elements that I have discussed so far that has to be run by the system. And only then it tells you what are your options, okay? So what AutoML does is it can do this iteratively, but it's important to do it properly so that you can get the right combination of all of these and the best tuned model for your exercise. Now, the outcome of all this is a tuned model. And then you can look at the tuned model's results to find out if all of this stuff that was done by AutoML, is it great or not? Okay, so now we know what AutoML does, right? So let's look at more of what is AutoML and why have we not heard about this with Oracle before, right? So everybody knows that Oracle Database 20C was announced in Sangam just a couple of days ago. And this is already been released to the cloud services. And at some point, it's going to be there for on-prem. One of the main features for 21C is AutoML, okay? And like I mentioned, auto algorithm selection, feature selection, and model selection are part of this thing. There are also 3 major algorithms that are very popular for data scientists to use. Now, these algorithms are available elsewhere. Some of these are, like for example, XGBoost is available elsewhere, and so is Adam Optimizer. What we have done is we have implemented these things in a way that can scale and run very efficiently within the database kernel. Now, why is that important? We'll talk about this a little later once we finish this entire presentation as to why all these things are important and why having it in the database is better than having it running somewhere as a process. So MSET SPRT is basically an algorithm that detects anomalies and it minimizes false alarms. XGBoost is a gradient tree boosting machine learning algorithm, which is a very popular method for regression and classification. So it's used for, rate prediction, hazard risk predictions, and web text classifications. But there are so many. I mean, XGBoost is actually one of my favorite algorithms. Whether using open source, whether using scikit-learn, TensorFlow, or all these things in the Oracle Data Science Cloud, or you're using OML, it doesn't matter. XGBoost is a really good time-tested algorithm that can be used for classification and regression-based problems. And now we have support of it inside the database kernel. When this gets released for on-prem, you'll be able to use these algorithms directly in your SQL queries without paying any money for it, which is pretty cool. Now, the Adam Optimizer, so there's a classification of problems called ARIMA. The Adam Optimizer is one of the other solutions within ARIMA for solving this kind of neural network problem, especially for anomaly detection. It's computationally efficient. It requires very little memory. And it's actually great for cases where there's large data or parameters or both. So Adam Optimizer is a pretty common combination. So these are 3 new algorithms that, in addition to a whole bunch of other algorithms that are already there as part of the Oracle database in the OML option. So this is already available right now in the Oracle Cloud. If you go create a free autonomous account, this will be available in on-prem sometime next year, and you'll be able to use these algorithms as part of your queries. Now, where does AutoML come into all of these things, right? Like I told you, it reduces the number of features, it looks for different combinations of algorithms, and it auto-tunes this. Okay, all that sounds great. It has a Python-based interface too. That's also new and that's coming. So in the autonomous world, like today I have a free autonomous database account. I have my application there. I have all the data there, right? I can use this as a citizen data scientist, to quickly create things. I don't need to write any code. I just have to pick the data and the target. The ML steps are automated. It creates multiple models. There's a leaderboard. And I can basically deploy this via REST. And if something goes wrong, it has complete support management built in. So basically, as an ML person, I really don't need to know anything to do all of this. And I'll show you a couple of screenshots of how you can actually get to this, right? So first, I choose my data set. Second, I choose what I have to predict. And then I start, and that's it. That's all I have to do. What this will do is will automatically take a bunch of algorithms. Now, the most important thing to see here is this on the right here, where it says it's feature ranking, algorithmic selection, adaptive sampling, feature selection, hyperparameter tuning, and then all the various algorithms with the parameters that have been passed to it. And the potential feature prediction report as to what it's doing here. Here are a couple of other things. The algorithms that they have been run, the actual algorithms correspond to these things. Like in this case, this is GLMR1. These are the deployment runs. These are the algorithms themselves. And these are the scores that correspond to the accuracy from running this. This indicates that it's still running. And this is the overall progress that's actually been made. And all I've done here is just pick the data, pick the lifetime, and give me a second. Let me see if I can do this. Yeah. So it takes these algorithms, it gets these scores, it does feature ranking, algorithmic selection, adaptive sampling, feature selection again here. And this is for iterating over all the algorithms. These are the features that it has picked underneath. This is the fact that it's running. This shows a metric chart over the score where it is headed. This is the experiment I have created. This tells me I can stop it. I can view the logs here. So you can see everything is basically there within the context of a single page. Now, where is all this stuff? When I go to AutoML, there's an option here in the autonomous cloud that'll basically show me that, hey, there's an option for AutoML. Once I click on this, I can create an experiment. The experiment indicates what I'm trying to do. I'm trying to target some customers. And I can pick my data source here, which is, if it's present inside the autonomous database, that's the best. And then what I want to predict, and the case ID that corresponds to this. So in this case, I've picked my data as supplementary demographics. That's the table that I'm trying to pick from my set schema. I have a whole bunch of target attribute values. This is the thing that I have to predict. And in this case, I'm picking affinity card. Now it shows you all the features here, and it shows you which ones are the possibilities that I can pick. Now, what if I have no ideas what these things are, right? I can actually rely on the system telling me the attribute importance as well. So let's continue with these screens, and I'll show you where the attribute importance aspect comes in. So based on the prediction and the case ID of customer ID, and I'm doing the prediction type as classification. So I have picked all of these. And if you notice a couple of things it's already done, the names of the columns, the type of the columns, what percentage of them are null, distinct values, and then there's min, max, standard deviation of all these values done up front. So I can have a good view of my data before I even start this experiment. And then it also tells me, because it's automatically running attribute importance, that it tells me some of the most important attributes are these guys here, the top 3. Based on the importance of the attributes, it's already calculated that these are the attributes that are most important that should be considered. Now, as it figures out, like as an example, if it takes this many attributes in the first run, it could drop these in and continue to only keep these 3 attributes to see if the scores are close. Why bother taking those extra 4 attributes? The system does this automatically for you. And then you notice these are the algorithms. Now, if you notice the names, these are for each execution. It creates the type of the algorithm and a random number after that. This indicates a unique run for decision tree on top of this data for this experiment. And this is the accuracy score that it has gotten from this. So if I deploy a model among any of these in my leaderboard, I can track it based on this. This is how I can track. So imagine this. I'm running 5 or 10 experiments, and I'm simultaneously doing a whole bunch of stuff. And I want to quickly find out what's going wrong where. This will help me track my specific combination of the model down so I can understand what went wrong in this situation. The same thing here. You can see I can create these notebooks, and then all of these various features, I can say, run this, check that. It's basically telling me everything that has been completed for all the various algorithms. And then finally, I can pick the name, version, and the URI. The URI specifies where it is. And then it generates the model metadata, the type of the model, the attributes that are taken, and the various labels that are generated. So this is basically an endpoint where I can deploy, a REST endpoint where I can deploy my model. I can take this into Apex. Once I built it in OML, I can take this into Apex, run the exact same SQL queries within Apex, and I'm using the results of the model that I built in OML directly in Apex. It is that powerful. So if you're doing one thing and the other, it's a SQL query. It can transparently be brought across, and you can use this in Apex. But what does AutoML not do? It still requires you to define the problem definition and requires you to clean the data and prepare it. That doesn't change. Machine learning works on data when it's already ready. It is not intended to replace any of that. But the rest of all the other complicated part of machine learning that I told you earlier that you have to manually run is all taken care of by AutoML. I want to cover this. This is a very common topic that keeps coming up. Hey, why should I not use GPUs and stuff like that, right? So as far as AutoML is concerned, it doesn't make any difference using CPUs and GPUs because AutoML is just a platform. Now, CPU cores are used for general computations and workloads, and specifically for data computations is where you use GPUs. Now, the most common case of using a GPU is basically for, like large-scale matrix multiplication type of operations, or for any kind of parallel execution for deep learning, autonomous driving, identification of images, translation of languages. GPUs are really good. And GPUs are very powerful, right? They have a smaller die. They allow many more GPU cores. And sometimes it can be 5 to 10, sometimes it can be 5 to 50 times as fast as running things. But there are very specific problems and depends on the experiment where the GPU benefits. In most of the use cases I have seen, which require you to use standard machine learning, GPUs did not help as much. So you could run the same thing on CPUs and you'll be just fine. So just ensure that whenever you're trying to write ML applications, you decide what sort of operations and experiment these things run. And if they can be parallelized, sometimes they can be parallelized on an extremely large number of CPUs that is actually more than adequate. Because remember, renting GPUs in the cloud is sometimes can be pretty expensive. The Oracle Cloud supports both P100 and V100 NVIDIA GPUs, the Pascal as well as the Volta GPUs that are available. So you can just allocate a machine and just spin it up, allocate the GPU and start running your experiment. But as far as AutoML is concerned, it really doesn't matter. But here's a couple of interesting things, and I'll probably use this as more like an ending thing for our presentation today. These are important considerations to take when you're doing AutoML. The data volume. When you have too much data involved, any modeling or scoring takes forever. Data movement. If you have to move the data from the object store and move it to the database or do something like that, depending on the impact of how much time it's going to take you to move the data, it's going to be a huge problem. So if the data is accessible inside the database, AutoML can process it just like that, not a big deal. If the data is sitting on a file system and I'm running XGBoost with AutoML, and running it directly in the data science cloud on top of the object store that's mounted on the machine that's running XGBoost, again, I'm not moving anything. But if I have to load something from another cloud and bring it to some other cloud and run something somewhere, or I have to move it from a block storage somewhere and move it to an object storage somewhere and then run something on it, depending on the impact of how much data you're moving, it's going to slow down your entire exercise for machine learning modeling. The third one, algorithmic choices. Algorithmic choices, depending on the amount of consumption they have. Like, for example, naive Bayesian and decision trees, they have far lower computational demand as compared to linear models or SVM. So the choice of algorithms you pick could define how fast or how slow the entire processing is. Data complexity. Data complexity meaning if the data table is easy to recognize, then it can be done really quickly. But some patterns are not linear, and hence they require a lot more iterations to identify. So the cardinality of categorical variables can determine or can significantly impact the performance of how long AutoML is going to take to figure out how to do adaptive sampling on your data. So your data complexity is an important part of this equation. The last one is algorithmic implementation. Many algorithms, especially some of the open source algorithms, and sometimes even proprietary algorithms, they're implemented in a non-parallel fashion or single-threaded fashion. So you have to look at this, that even if you run this on multi-cores or you run this on GPUs, nothing's going to happen. So all those algorithms I mentioned to you that we run inside Oracle, they all work with PQ. So natively, those things can run in parallel across the database kernel and give you the same scalability that you are used to when you're running queries like materialize views and you're building and running large joins across various Oracle tables. So the algorithm is not the only factor. The fact that the algorithm can be parallelized significantly also impacts the scaling consideration for AutoML. So these are important considerations for AutoML when you're picking different algorithms. As you build more complex models and you want them to scale, you will use this to decide how much resources on the cloud you're going to use and all of those aspects. So coming down to conclusions, so Oracle Machine Learning is a pretty cool option. It has a whole bunch of stuff. It has 30 plus powerful database algorithms that are available in the DB, and it has AutoML UI, which is part of the autonomous database. Things that are coming for 21C, OML for Pi, which is Python API and OML notebooks, embedded Python executions, REST APIs, AutoML, a simple UI where you don't have to do much coding. And it also has support for time series as well as anomaly detection. Then there's OML services, which is basically REST API deployment for models, as well as Onyx for the network exchange of data, the standardized network format for exchange. And then there's OML for R, which is embedded R execution, which is also going to support a REST API. And all those new algorithms like XGBoost, MSET SPRT, as well as the Adam optimizer that I mentioned, and OML for Pi. That will also go back and support. All of these will work on on-prem, cloud, as well as on DBCS, which is also our database cloud offering. To conclude, Oracle has this message of converged database and analytics. In combination with OCI data science, Oracle machine learning, database and analytics cloud, it basically can satisfy most of the machine learning related activities using powerful ecosystems like AutoML. So if you haven't gotten started with machine learning and you were still terrified of it after my presentation last year in Sangam, now's your chance to basically take it on. Because remember, you don't care about the algorithms, you don't care about the adaptive sampling of data, you don't care about any of this. You just pick the combinations, it will tell you the right scores, you run the experiments, you click and deploy the model to a REST endpoint, you run this in an Apex report, and you're done. You could be done in 30 minutes without understanding any of the internals of how exactly this stuff works. So this is a very brief introduction to AutoML. I hope it was useful. And now we'll probably take questions. By the way, people ask me, how do I follow you and stuff? So that's my Twitter, that's my LinkedIn, that's my slide share. I've uploaded all my previous presentations here. This presentation, you will get it once this Sangam conference completes, and you will be able to download this from the AIOUG site. All right. Questions? All right, let's look at this. What do we have here? Any NLP related features available with 21C? Not as part of OML. There are some NLP features available in the Oracle Data Science Cloud. The Data Science Cloud is a generic environment that allows you to run any open source stack. So any NLP feature available with TensorFlow, XGBoost, anything with PyCharm, all of these utilities, you'll be able to exploit those with the Data Science Cloud, but no NLP specific features that I know of with 21C database natively. For an admin, DBA apps OS admin, what is the starting point to learn AutoML? Is it a software that can be installed and used? Same context for developers. The cool part about AutoML is there's nothing to install. So remember what I told you, right? It's like if you install a platform, right? You're kind of spending too much time on this. Focus on what you need to do. Here's some data, here's some analysis that you have to do. And all of this other stuff in between is just something you have to get through. So if you have a bunch of tables in your database, and say as an example, you're using autonomous, you can just go and click on AutoML, pick your table, pick the input predictors, pick the output variable you want to predict, and say go. And it will automatically run this combination and say, this model is the best. Click on the model, click on deploy, done. That's the fastest way you can get started on this. If you want to use some of this stuff on-prem, you have to wait for 21C to release on-prem, where you can also use this. Some of this AutoML stuff is also available in the Oracle Data Science Cloud, but that is not tied to the Oracle database per se. It's not OML. It's basically all the open source configurations from scikit-learn, TensorFlow, XGBoost. You can run all of those frameworks, Dask, and you can run those natively inside the Oracle Data Science Cloud. So what that does is basically stitches all the open source frameworks along with the OCI hardware and APIs and SDKs. And it's a complete platform for tracking the same thing like what we have in OML, except in OML, I'm not using third-party stuff. I could if I want to. So with OML for Pi, you can actually connect to, say, scikit-learn libraries and run them against pandas data frames that load data from a backend table that's running on OML. You could do that. But OML is very good when your data is sitting inside Oracle and you're running everything through SQL. You don't have to do that. You can switch to Python and that also. But for Data Science Cloud, you can do that with Python, with any of the open source variables. You basically get an IaaS server, CPU/GPU, where you can do this. If you have no ideas of how this works, that's kind of the idea. You should not have to know how it works. You should just know how to use it. It's like, a new version of the Oracle database comes out, 21C. Do you know how the SGA works? I'm sure some of you smart people know how the SGA works. Do you care how the SGA works? Probably not. As long as I don't have out-of-memory exceptions, I don't get Aura 4031s for shared pool, and things run smoothly, my buffers are cached as much as they can, I don't really care how the SGA works. AutoML and machine learning are kind of like how the SGA works. As long as you understand how to apply these tools to the data to get the answers you want, the rest of it is irrelevant. It should not matter. So the fastest starting point, how to leverage AutoML. Autonomous Cloud, create an account, use AutoML out there. Next question. Do we really need data scientists when we have machine learning? First of all, do we need data scientists? Yes. When we have machine learning, yes. Once AutoML is more advanced and mature in the next years, yes. I answered this question. It was part of my presentation. All these frameworks can automate repetitive tasks. There's still going to be the idea of looking at the data and finding out, is this model look right or not? What are the various inputs to it? What should be the predictors? What sort of combination of adaptive sampling does it do a good job? I need humans to verify the outputs of these models. I need humans to tell the AutoML framework what data to massage against and what to look for. The models are not smart enough to do that yet, but there will always be a space for data scientists. Next question is, data scientists will be in the same position as Oracle DBAs with the autonomous database. I honestly don't think so. I don't know what position you're talking about as Oracle DBAs. Oracle DBAs are used to doing a whole bunch of stuff, okay? There are DBAs that do just backups and installs. That role is slowly disappearing away. But there are DBAs that do modeling, performance tuning, optimization, online upgrades. There's so many other things that DBAs do. And DBAs will continue to do that because there are millions and billions of Oracle databases all throughout the world that will not disappear anytime soon. Even though people would like you to think that's the case, that's not going to happen anytime soon. But it depends on the task that you are doing. So if you are driving a car and 10 years in the future, all the cars are driverless, and you insist on driving a car, then your insurance will be 10 times as much as the cost of a guy who just sleeps in the back of his car. So there are certain tasks that are always going to go away, but the role doesn't disappear. There are other tasks in that role that will become more prominent. It's a process of creative destruction. It happens everywhere throughout the planet, right? The same thing that's happening with the Oracle DBA continues to happen in the data science positions. You cannot say, I'm just going to do model building and that's great for my career. You need to understand how it works. You need to apply as many models as you can to your examples. And you need to make sure you indicate value to your organization. As long as you keep doing that, and you keep finding newer and newer use cases to solve business problems, it's not going to happen. Do you recommend ML over data science? They're one and the same thing. They're just a field where you actually deploy or use mathematics and machine learning algorithms or deep learning. All of these are kind of intersecting. They're just fields where the study of application of mathematical algorithms on top of data to provide efficiencies and solve complex problems. So they're basically the same. Very interesting session. Thank you, sir. It's nice to see how one can have continuously using ML and Apex. Can you please share the link where we can use AutoML? Autonomous database, 21C, you can go and use AutoML out there. A lot of the features I spoke about are still coming. So we'll keep rolling this out over the next 2-3 months, like all the OML for Pi and all of these features will be coming. It will take some time for all these things because we just announced 21C when Sangam started. So please have some patience, enjoy your Christmas. Over the next couple of months, all these features will be rolled out. How much data is the right size to get to some useful meanings from ML? That is not an easy question to answer because it depends on the experiment you're running. Some experiments we have run doesn't require too much data to get the answer to whatever you want. Some experiments, you need a lot of data to get a better size. So it's like, how do I do this? Okay, so you're trying to catch a local train in Mumbai, okay? And I go to the train station and I'm like, 7 o'clock in the morning. Is this train going to be late? It's raining, but there's a crowd and there's no traffic and everything seems to be okay. The tracks seem to be okay. There's there's no submerged tracks. There's no crazy people running across the tracks at this point. And I think the train's going to be on time. But I have a data set of this train for the last 15 years of how many times it's come, how many times it's been late and stuff like that. So I can actually use that data set and predict exactly what time this train is going to come based on the past data that I know. So that's an example of I have data and I have enough data to predict a very useful problem for this. Another case is what happens to the cats and dogs on the street when there's a shutdown. I don't have much data because when Mumbai was shut down last, it was shut down for maybe a month in the last 70 years. So we collected some data. But now if I say, oh, there's going to be a shutdown and Modi comes and says there's a shutdown in India, nobody's going to go home. The streets are not going to be empty. I'm never going to see the cats and dogs run happily on the street like how they used to run during shutdown. So because of that, there's no way for me to know or predict because I don't have enough data. I just have a few days and I can say maybe they're going to run happily because of these 3 or 4 days of data that I collected when we had the shutdown. So some problems do not need too much data to, I can take 1 week of data and tell you the train's going to be late. I don't need 1 year of data. Just 1 week is good enough. But in the other case, I need more data about the cats and dogs before and after shutdown, before I can predict if they're going to happily run around. The answer is most likely they're going to be happily running around. So the answer is it depends on the experiment. Can you please share machine learning libraries and videos? I'll put a slide in my deck that will have a whole bunch of links to videos, presentations, everything that you can download related to Oracle machine learning. How do we use AutoML performance analysis of the database? So AutoML is used for different use cases. If the input is AWR data, then you can use it for analysis of the database performance itself. Now we use, for this, you also have to look at some of the other presentations that I have done in the past, where we use machine learning to predict performance of the database. But all that is within Autonomous. We don't release this as a software stack. Can we build models that are self-learning since the effectiveness of the model drops over a period of time? That's what AutoML is exactly for. You keep continuously running on the newer iterations of data. As you keep running this and generate new data, you could feed that back into the adaptive sampling framework and train newer kinds of data and newer kinds of testing data. And that will continuously evolve the model over a period of time. The whole idea is to submit all this to the AutoML pipeline so it continuously keeps giving you newer stuff. You have to keep an eye on it because if the model regresses, it will severely affect your ability to use that output to do what you really want to do. So yes, that is exactly the kind of use case that you do AutoML for. In 21C, with all these features, it gives enough new stuff for developers or changes the way DB is being managed or administered or a combination. I don't know whether this is a question or not. And the answer is yes. It basically allows DBAs and developers to do a lot of stuff that they were not able to do before. There's a lot of developer flexibility. You should look at the slides that come from Juan Loaiza or Andy Mendelsohn or Jenny Tsai to see how developers and developer related stuff, like developers can directly access a database today and just go and do whatever they want to do with, either using JSON or either using graph databases. There's so much of features in this thing. Oracle was never scarce on features, but the way we have bundled them, the way we are tightly integrating these features among each other, you don't have to log into 20 services and 20 different systems to connect and build all this framework. You can just connect to one thing, write your SQL queries, you're done. So you should look at presentations by Jenny, Andy, and Juan to understand more of this. Last question, I think we're out of time. AutoML chooses the winner from the trained test data sets. Once we get additional real world data, we can apply or score the winning model against the newer data. Yes. Is there a way to score the other models, remaining non-winning candidates, against this newer world data? Yes. That's exactly what it does. So the thing is, every model run generates a value. You can compare those old values with the rerun values. Remember, every time you run AutoML, it reruns the combination of algorithms, adaptive sampling, hyperparameters with the new data. And you can compare the results of the new data with the old data because that's already done, right? That's basically what it does. It allows you to compare the combinations. So it's already doing this. And you don't have to rerun it back with the old stuff because it will automatically run it with the new stuff. You have the score from the old stuff. You have the score with the new stuff. You compare the scores and see how well the model is changing over a period of time with different data. It may be the case that AutoML chosen model is not the winner against the real world data collected from production. Yes, that absolutely could be the case. Can it help switch between the candidate models once newer data comes into play? So you remember I told you, each model has that unique number. And when you deploy, you have to specify the URL you want to deploy and what model you want to deploy. So as a human, you have to make that decision, okay? Automated model deployment is sort of never encouraged because you don't know what the heck this thing is going to do. If the model is wrong, it's going to completely trash your site. So you can switch from the old model that was previously deployed to the new model, and you could A/B test this against a smaller set of people and say, this service, we're going to do this. This service, we're going to do this. And then see for the new service how well your model performs. If that's the case, you can expand the REST API to say that this backend is now the main backend, and all the connections coming from this web server and the load balancer are going to be redirected towards this URI where the new model is deployed. So all of these cases are precisely why you have AutoML. All right, I think we're done.
Thank you very much. More energetic speaker, rockstar Sandesh Rao, and definitely we are missing you face to face. Hopefully, we'll see you in Yatra, subject to COVID-19. Okay, excellent. Okay, again, guys, if you want any, I'm not saying, go and bother him in the social media, but, if you just follow him, you learn a lot of things, the energy and the subject knowledge and, whatnot, right? So Sandesh is really a motivational for us.
My secret is a small little glass of bourbon. You have a little glass of bourbon and you can do how many of presentations you want.
And by the way, more funny guy. Okay, so look at this QR code and it's time to check your knowledge, and please participate and win some gift vouchers. Okay, I'm taking out.
Thank you.
Okay, recognition program, all about this program. Basically attend more sessions. 1 minute equal to 1 knowledge point, and if you attend a keynote session, you'll get 2x points. And also make sure that you tweet in social media, then you get more points. And congratulations to all these people appearing in the leaderboard. I think Durga Aditya crossed Rangarao. Thank you. Congratulations. Go into this particular link or go to the home page. You'll find this knowledge points and look at your points where you are.
Hey, both of these are my friends, man. I know both of these guys.
Yeah, they are very prominent people attend most of our sessions. Okay, tomorrow there's a big session is going to come. Means tomorrow morning, same time. We are also inviting Sandesh, not a technical talk. It's more of open mic. We'll unmute everyone. Just we'll prepare agenda. Okay, and we will explain about what is the community, and let us have a more of a rapid discussion and more open mic. Anybody can just come and give a feedback. And if time permits, Sandesh is also planning to join the session. So make sure that Sunday morning 10 to 11, with your breakfast or whatever, tea or coffee, join this session, right? So with that, we are getting another, analytics session from Lalita. Please join. We'll open in next 15 minutes. So with that, we are closing this session. Thank you very much, Sandesh. Hope
Thank you,
we'll see you
guys.
tomorrow.
See you guys. Enjoy the rest of the conference.